Welcome to Chapter 7.3, Simplifying Radicals. Today we're going to talk about how we can simplify square roots and cube roots, etc., and get it into the most simple form. So let's begin with an example. Here we have the square root of 4 times the square root of 9. So there's two different ways you can really think about this. So the first is you can think of it as the square root of 4 times the square root of 9, and you can put that all underneath one radical. Okay, so then we have the square root of 4 times 9 is 36. So then we have square root of 36. Okay, or we can do each one separately. So the square root of 4, I don't know why I keep putting the 4 first. The square root of 9 times the square root of 4. Okay, that becomes 3 times 2 because the square root of 9 is 3 and the square root of 4 is 2. And now we're going to see if both of these equal the same thing. Square root of 36 we know is 6, and then 3 times 2 is 6. So we get the same answer regardless of which method we use. So that's kind of like the standing principle of how we are going to simplify these radicals. So just a quick addition to this, so we can extend it a little bit further. We have the product rule for radicals, and the product rule for radicals states that if we have the nth root of a times the nth root of b, then we can write it as, let me use green for a little bit more contrast. We can write it as the nth root of a times b. Notice something very important. These indexes, this is an index, and this is an index. This tells you what kind of root it is. They need to be the same. If they are not the same, then you cannot combine A and B underneath one radical, okay? So let's look at a few examples to get us warmed up. If we have square root of 5 times square root of 7, we can rewrite this as the square root of 35. Because these both have the same index. Now, I know you're thinking there's no index written there. If there's no index written in terms of a number, then it's implied that it's 2, that it's the square root. Next up, we have radical 11xyz times square root of 7. The only thing we can really combine in terms of multiplying underneath the radical, because the indexes are the same, is the 7 times 11. So we're going to write this as 77 times xyz, or just 77xyz. That's a pretty nice radical sign right there, if I may say so myself. So now we have a different case. This isn't a square root. We have the cube root of 3 times the cube root of 12. Now, again, the indexes are the same. Okay, so we have the 3, oops, wrong thing. We have the 3 and the 3, and they match. So we can go ahead and combine these all underneath the same radical. So let's set this equal to the cube root of 36. Okay, now we have the 6th root. It's the same thing. Because the indexes are both the same, we can rewrite this as the 6th root of 50m to the 4th. Now here we have a case where the indexes are not the same. Here we have this one is equal to 4, this one is equal to 5. Therefore, we cannot combine these any further, and we need to leave it as is. There's nothing more we can do. And that's a 5. I know that just looks like a squiggle, but you get the point. It just needs to stay the same. Okay, very similar process. If we have the power rule, we have the quotient rule. Product rule, we have the quotient rule. The quotient rule says if we have the nth root of a over b, we can rewrite it as the nth root of a over the nth root of b. Okay, this makes problems a lot easier to think about, so we don't have to worry about simplifying fractions, really, and we're going to look for cases where we have perfect squares either in the numerator or the denominator. So if we have square root of 16 over 25, we can rewrite it as square root of 16 over square root of 25, and that equals 4 over 5. Okay, now we have square root of 7 over 36. We cannot simplify the square root of 7, so we're going to leave that as it is, but the 36 we can rewrite as 6. Okay, essentially what I'm doing is I'm doing what I did in example A. I'm just taking the square root of the top, square root of the bottom, and simplifying it from there. Now I have the fifth root. You can do the same thing with fifth roots. We're going to put the fifth root of x in the top, the fifth root of negative 32. Because this is a negative number, the only way you can take the root is if this is an odd power, and it is, an odd index. So we're going to think what times itself 5 times gives us a negative 32, and that, of course, is negative 2. You could also rewrite this as negative fifth root x over 2, but I like it. Either way is fine. I kind of prefer the negative in the top. Finally, we have the cubed root of m to the 6 over 125. We're going to take the cube root of m to the 6, and that's going to, what times itself 3 times gives us m6, that's m squared, over 5, but we cannot forget the minus sign out in front. I like to apply the minus sign just to the top, and there you have your answer. Okay, now that's kind of some of the properties we're using for simplifying radicals. Now we need to get into the nitty-gritty of how to actually do it. So there's 4 rules that you need to know in terms of simplifying a radical. Number 1, no power is in the radical is bigger or equal to the index. Okay, so that just essentially means if you have something like 4 squared and it's inside the square root sign, you can simplify that. You should not leave it as the square root of 16. That is not simplified. Okay, whereas something like square root of 5, well, that's 5 to the first power. That doesn't have any factors, so that's as most simple as it can be. 16, that's not the case. You need to simplify this further. Okay, this can be rewritten as it's shown here as the square root of 4 squared, which of course is 4. Okay, here's some other examples. We have the cube root. We have a x to the 4th power. This one can be rewritten as the cube root of x cubed times the cube root of x. So then we would have that's equal to x cube root of x. Of course, this one's 5, and the next one I'm going to show different. I'll show that. I'll do it right now. Why not? So this one is 5. Okay, so this one can clearly be rewritten because that can be rewritten as 5 squared. Notice how the power is equal to the index. So 2 is the power. 2 is the index. There's an implied 2 there for square root, so it's equal to, so we can simplify it. I know you're thinking for square root of 18, that one doesn't look like it has a power, but you can rewrite this as the square root of 3 squared times the square root of 2. 3 squared is 9, 9 times 2 is 18. That's where I got that from. Notice how 3 squared has an index of 2 and the power of 2, so therefore it can be simplified. So this could be rewritten as 3 radical 2. Now basically, if for all those a little bit confused, essentially what this means is there are no perfect squares. No perfect squares, cubes, etc. Okay, so if there's a perfect square within your square root sign, then it's not simplified. You need to do a little bit more. The radicand has no fractions, so there shouldn't be any fractions in the radicand. You need to get rid of those if possible. So then we have this. We should simplify to square root of 9 over square root of 4. Okay, now there's no fractions in the radicand, and now it can be 3 over 2. We can simplify that further. The denominator has no radicals. I'm going to show you that a little bit later, but you cannot just leave it like that. So if you have 5 over square root of 4, that's going to be 5 over 2. And then this needs to be simplified. I will show this in a later video. Okay, and then the final rule for simplifying a radical, radicand and index have no common factors. So here the 6 is not equal to or greater than the 9, but it doesn't matter, they have a common factor. This is most easily seen in this example when you change it to a rational exponent. So the ninth root can be rewritten as the power of 1 to the 9th, and if you multiply radicals here, or excuse me, exponents here, you get 6 times 1/9 is 5 over 6/9, you can reduce that fraction to be 5 to the 2/3 power, and then you can rewrite that, part of my stumbling, 5 squared to the third root of 5 squared. Okay, so these are the same radicals. One is just more simplified because they have common factors. 6 and 9 both have common factors. I'm going to pause here. We're going to go over the next couple examples together in the part 2 of this video, so please stay tuned to see those.